Hello everyone. So today is gonna be our day 26 of the DSA challenge. And the question that we're gonna solve today is find the middle of the linked list. So this is the question, and it's a very easy question since you can see here that here easy is written. So the question states that given the head, or let me just turn on my video as well. Yeah. So given the head, right? Of a single linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle. So see, 1, 2, 3, 4, 5, and 3 is the middle one. But if the length of the node of the linked lists is basically even, right? So what you can do is you can find the half of it, and that's the plus one of it. So 4 will be your middle one, right? So till from 4, 5 from 4 till 6. So this is what you have to return. Basically, you have to return a node, right? Here you can see that return type is a list node. Let's try to see what the question states, okay? So see, you are given a linked list 3, 4, and probably 5. Let's take this example, okay? What will be the mid of it? So 2 from this side and 2 from this side. This is the middle, right? But how can you reach this? Okay, I don't know the length of the linked list, right? So naive approach. I guess it's either a German word naive. I'm not sure because I've seen somewhere that two dots are put on I. So okay, yeah. So naive says that hey, you have to find the middle one, but you don't really know like where is the middle, right? Because you don't. So see, when we are given an array, let's just say this is given an array and it is of length 4. We know that hey, it is of length dot length is nothing but 4. So what you can do is you can just divide it by 2. But here we don't know, right? We don't know what we can do to find the length of the um, basically the list, right? What I can do is see, this is the head given, correct? I can mark it as temporary. Okay, no problem. I can keep a counter. Okay, this is 0, right? Then as it comes on this, basically it comes on this becomes 1, this now comes to this becomes 2, this becomes 3, and this becomes 4. Basically we have traversed the whole array, right? We have traversed the whole array, or not array, basically linked list, and we can now find that hey, as soon as it goes out of this, as soon as it turns to null, basically increase it and break out of the loop, correct? And now you can find that the length of it is 5. Cool. What is 5 divided by 2? I know it is 2. Basically, you have to take the floor of it, right? You have to take the floor of it for sure, correct? So 0, 1, and 2, right? Or you can take the seal if you are starting from 1, whatever you are doing, right? Whatever you are doing. Cool. No, now I know that hey, as soon as I traverse to 2, basically the third from it, or maybe let's just take the seal of it. Okay, let's just take the seal of it. Cool. So seal of this is 3. Cool. Now I know that hey, 1, 2, 3, 4, and 5, right? This is pointing to null. Cool. Again, my head is here. I point my temp again to here, to my head only, right? Do you notice something that I'm not moving my head? This is because I want to keep the reference of my head, right? I don't want to give away just this. Because if I'm in the first iteration, what if I move my head? It now points to null, right? I won't get my reference back to of my temporary, right? I won't get my reference back of 1, right? Because I've already traversed using head and now it is pointing to null, right? Okay. Now temporary is at this point. Let's just say we take another counter, maybe mid, or let's just say flag, right? Okay, pointing to 0. Cool. Or maybe 1, since we have taken seal here. Since we have taken seal here, right? And temporary is already on the head. Let's take it as 1. Cool. Let's move temp. It becomes 2. Let's move temp here. It becomes 3. What was the answer expected? 3, 4, 5. Where is my temp right now? Do you notice something? Wasn't this the required one? So if flag becomes equal to basically my count, right? It becomes equal to my count. Or what is this? Basically, I can say that, hey, this is now equal to count only. So count will be count divided by 2. I mean, obviously, you must have noticed. As soon as this is true, I can return my temp, correct? I can return my temp, correct? Okay, cool. That's what I'm trying to do here, right? And if you see, if I return temp, temp is pointing to 3. This is what I require. This is what I require, right? Okay. Let's now take an example of something that we have in basically in even in odd positions. Okay. Sorry, now in even length. 1, 2, 3, and 4. Okay. Assume this is the one. Now I will find that, hey, sorry, hey, count is nothing but 4 divided by 2. That is nothing but 2, right? That is nothing but 2. And I need to return 3. If you remember, I need to return the second number. If there are two middle nodes, I need to return the second one. That is this one. Cool. Okay. How can I do that? In this case, I can take flag from 0, right? In the earlier position, I took it from 1, remember? But now I'll take it from 0. Cool. My temp is here, head will be here, right? So temp, as soon as temp comes here, temp becomes 1, then it comes here, right? Or maybe I can take another, right? It becomes 2. Now, as soon as this becomes equal to it, I can now again return my temp, and this will be my required answer. Correct? Correct. Yes. This is what I'm talking about. Okay. So, what is the time complexity? O of n to find out the length of the linked list. Okay. O of n by 2 to traverse the basically traverse the whole till the mid of it, from where we'll return the temp, right? This is the time complexity, right? And space complexity is nothing but O of 1, because we are not taking any extra space. The interview might tell you that, hey, I don't want you to do it in multiple passes. I want to do it in single pass, right? From only by O of n and not this additional time complexity. Okay. How can you do that? Let's find that out. Optimal. Okay. So 1, 2, 3, 4, and 5. This was our initial example. Okay, cool. Let me take some other pen now. I will put 2 pointers here. Slow, fast. Okay, and this is now pointing to null. Don't worry about it. I will move slow. If you remember my video, if you remember a previous video where I discussed the slow and fast pointer, right? The video that I'm talking about is find the duplicate in array of n plus 1. I'll do one thing. What I'll do is I'll you know I'll just put this video's link in the description. You can find it out there as well. So in this video, I've talked deeply about slow and fast pointer. This is also called tortoise hare, rabbit, rabbit turtle approach, Floyd cycle approach, Floyd cycle algorithm, right? and whatnot. There are multiple names to it. And I told you that, hey, I will move my slow pointer by 1, fast pointer by 2. This is what we discussed. Yes, let's try to do that. Okay, cool. Slow comes here, fast move here. Slow comes here, fast moves here. Correct? Is this what I require? Is my slow pointing to somewhere that I wanted? Yes, right? Yes, okay. Let's take some other example. Don't worry about it. Let's take an even example. 1, 2, 3, 4, 5, 6. This is even length. Okay. Let's try to do the same thing. Slow here, fast also here. Slow move 1 position, fast move 2 positions. Slow again moves 1 position, fast again moves 2 positions. Slow moves 1 position, fast becomes null. Fast becomes null. Where is my slow? Slow is at my second position, which I required. Which I required. Had I been given that, hey, return the first middle node, I would have stopped here, or else I will stop here. You have to notice two conditions. You have to notice two conditions. Okay. Now, what is that condition? Okay. I am stopping my fast pointer at two positions. Either, not either. I should not write when first point fast dot next is equal to null, and second is when my fast becomes equal to null. Is this what I'm doing? Still here when I was here. Fast dot next is null, correct? And here fast becomes null. In these two positions, I'm making it basically what I'm doing is I'm stopping this loop. Let's try to write the pseudocode for it. Cool. Hey, while let basically my slow pointer is equal to head and fast also equals to head, both are pointing to same position. If my fast is not equal to null, and why and I'll tell you. Fast dot next is not equal to null. Okay, I need to stop. Okay, what I'll do here, slow dot next fast is equal to fast dot next, and simply return slow. Oh, sorry, fast is equals to next dot next, right? Because I'm moving it by 2 pointers. Let me ask you one thing. Let me ask you one thing. If I am given a node like this, what will be the next of it? Will will it not be null only? Null is something that is undefined. You don't know what it is. You don't know what it is. It is not a 2D value basically, right? It is not a 2D value. So null's next is also null, right? You don't know where it is. So basically if I say that, hey, infinity plus 3, what if I say this? It is nothing but infinity only, right? Because you don't know how much is infinity, then how can you add 3 to it? I know what 1 plus 3 is, right? I can say that, hey, I know how to count 1, I know how to count 3, I can say it is 4. But if I don't know what infinity is, how can I add 3 to it, right? So it also becomes infinity only, correct? This is what I'm trying to explain to you here, that hey, if fast is equals to null, and fast dot next also is equals to null, then only you need to stop this loop. Then only you need to stop this loop. Okay, cool. That is why this is important. You cannot put an or condition here. You cannot put an or condition here, right? You have to only stop when both of the situations are true. Double it. Let's try to code it out. I hope you already know what time complexity is. We are not taking an extra pass, so O of n, a single n, and O of 1 space complexity because no extra space is being taken, right? This is only one single pass. Great. Let slow is equal to head, correct? And fast also is pointing to head. While fast is not equal to null, double equals to basically a hard check, and also fast dot next also is not equal to null. Then do something. Do what? Move slow by one pointer, move fast by two pointers, correct? So slow, you move by one, fast, you move by 2 points. And where will my new head be? It will be nothing but slow, because slow will be pointing to it. Let's try to run this code. Great, accepted. Let's try to submit it. Great, accepted, right? Only 3-4 lines of code, and what it did, you already can see. It found you the middle of it. Here, if you remember, we had to write two passes first, O of n pass, then O of n by 2 pass, right? Plus, we need to write some other code, uh, initializing flag, initializing count. Then we have to check if count is divisible by 2, then flag should start from 1. If it does not start with, if it is sorry, if count is divisible by 2, you have to start your flag with 0. If it is not divisible by 2, you have to start your flag with 1. But here, if you can see in this approach, right, the optimal one, we did it in just 4 lines of code. That's it. That is the power of slow and fast pointer. It will be very, very beneficial for you if you know slow and fast pointer. Easy, simple, slow, and fast pointer approach involved. And slow will eventually be present on the mid. Let's save it and mark this as done. I hope this was a very easy question and a very beneficial one because you got to know one more uh, basically an algorithm. I'll see you tomorrow, guys, with another question called merge to sorted linked list. I don't know. I don't think this should be a very difficult one, but yeah, we'll see. Okay. Thanks so much, guys. Bye bye. See you tomorrow.